So let's look at ordinary annuities. So that's when the investment comes at the end. So borrowing money. That's what we said before. The difference between annuity due and ordinary annuity is where we make the payment or the deposit, depending on whether we're talking about an investment or a loan. Remember, future value turned out to be that. It was just our geometric series. P was principal, interest rate, time periods for N. Okay. We also saw that present value, R to the power of N, was equal to the future value. So that was the formula we came up with for present value. Okay, loan repayments. The amount still owing after N time periods is always this. Just think of it like this. Amount N, principal plus interest applied minus installments plus interest applied. And that's it. That's all we've got to worry about. Okay. Richard and Kathy, they're going to borrow $20,000 from a bank to go on a holiday. Not a bad holiday, $20,000. Interest is charged at 12%. I must have written this example a very long time ago, because if you're being charged 12% at the moment, find another bank. They start repaying the loan 1 month after taking it out, and their monthly installments are $300. How much will they still owe the bank at the end of 6 years? The initial loan is borrowed for 72 months. So that's the first thing we work out. That's the first part. Principal plus the interest. So we work it out. $20,000 times 1.01 to the power of 72. Conveniently, I made the interest rate 12% per annum, because then converting to per month, nice and easy. But what you got to understand, repayments are actually an investment. Because it's like this. You have borrowed this money from the bank, okay? So that's like the bank is making an investment in you. But when you start paying it back, it's now like you're giving the bank a loan. You're saying, hey, here, have some of my money. And when the two balance, you've paid the loan back. So repayments are an investment in your loan. So how much are these investments worth? My first repayment will be in the bank for 71 months, because I'm going to put it in at the end of the first month. So it'll be worth 1.01 to the power of 71. The second repayment will be in there for 70. So exactly like we were just doing. And we will keep going and we'll keep going. The second last repayment will be in there for 1 month. And then this is the one where the last repayment, well, it's going to be in there for no months. So it's simply $300. They, added together, will be the installments plus the interest. So the difference of the two is the amount owing. Therefore, we said after 6 years, wasn't it? So we want to know what amount 72 is. Principal plus interest, there it is. Installments plus interest, what we just worked out there. Add them all together. That's the geometric series, so I just got to plug it into the formula. It's just number crunching now. $9,529.01. How much interest have they now paid in those 6 years? Well, they've made 72 repayments of $300. So they've actually given the bank $21,600, but they've only reduced the loan by $10,000, right? Because they've still got $9,529 owing of the $20,000 they borrowed. Well, the difference in the two must be the interest that you've paid, the extra money that the bank's getting. So the bank's managed to make $11,000 and a bit. What about if you want to do this? Now look, before the days of the internet sucking the fun out of maths, when you wanted to get a loan, what you would do is you would sit down and you would calculate, because you knew how much you wanted to borrow. You could sort of work out how long you wanted the loan to be. You say, well, how much am I going to be up for if I want to take out a loan? So here you go. Yog. Yog. Sorry, full name, Yog Chopra. Student I taught quite a few years ago now. So Yog borrows $30,000 to buy a car. Yog was going to repay the loan in 5 years. So there were 60 installments. And at that point in time, interest was charged at 9% roughly. So how much are the monthly installments Again, all I'm telling you, this was before the internet. So I actually would sit down and go, work this out to see, can I afford this loan? I don't know what the monthly instalment is, so I'll just call it M. Now this initial loan that I want is going to be over 5 years, so I know what that's going to be. But my first repayment will be in there for 59 months. My second one, 58 months. And so on and so on. The second last one will be in there for 1 month, and the last one will be in there for no months at all. So amount N will be the principal minus the instalments. But do you think, the thing I know about amount 60 is it's got to be 0, because that's when the loan's paid off. So solve that little equation and we can see what the repayments are going to be. Where are we? There we are. $622.75 per month. What about, you know how much you can afford to repay? Okay, so, but we want to know, well, how long am I going to have to take this loan out for in order to get the money that I want? This is HSC one. So Wheelbarrow Back Shire Council, they borrowed quite a significant amount of money, but they're a council. $3 million at the beginning of 2005. Annual interest rate, 12%, that's nice. Divides by 12 easily. Each year, interest is calculated on the balance. Debts to be repaid by annual repayments of $480,000, first being made at the end of 2005. Amount N be the balance after nth repayment. Show that. So they've given you what the answer should be. Well, let's do it. The initial loan, it's only for 2 years now we're looking at here. So principal plus interest. First repayment will only be in there now for 1 year because we're only talking 2 years. And then the second repayment will be in there for 0 years. So it's just these two. So principal plus interest minus installments plus interest. Well, it's not quite what they want, but we can get it there because if I just use scientific notation, we've got it. It's 480,000 is 4.8 times 10 to the 5 and factorise that bit and yep, we've got what they wanted. Show that. Okay, so now we don't know how many years. So it's power of N. First repayment will be in there for N minus 1 years, then the next one N minus 2 years and so on and so on and so on. And the last one in there for 0 years, principal plus interest minus installments plus interest. So let's work out what N is. Well, actually not work out, we've got to try and show it's that. Amazingly, how lucky are we? 480,000 divided by 0.12 turns out to be 4 million. I can expand that out. There's a common factor there, eventually, of 1 million, which is, of course, 10 to the power of 6. So we do get the expression they want. In which year will the final repayment be made? So now we just have to solve that equals 0, and eventually, there it is, 13th repayment. 2020 HSC. So this one, the significance of this one, 2020, first year of the new course. This was question 26. Tina inherits $60,000 invested in an account earning interest at 0.5% per month. Each month immediately after the interest has been paid, Tina withdraws $800. The amount in the account immediately after the nth withdrawal can be determined using this recurrence relation. Who would have thought, not only do we look at recurrence relations in Extension 2 Maths, here it is in 2-Net Maths. Okay, use the recurrence relation to find the amount of money in the account immediately after the third withdrawal. So amount 3 would be amount 2 times 1.005 minus 800. Amount 2 would be amount 1 times 1.005 minus 800. Amount 1 would be amount 0 times 1.005 minus 800. Expand the whole thing out. And look what we've ended up with. Essentially is what we had before. Principal plus interest minus, we've ended up with exactly the same thing, which we can calculate out. 58,492. Calculate the amount of interest. Well, interest, 58,492.49 plus 3 times the repayments, right? So the amount owing plus the repayments we've made minus 60,000. So balance, which was how much we borrowed. There we go. 892.49. How much is in the account immediately after the 94th withdrawal? Principal plus interest minus, that's still the same idea. Sub it into our formula, 187.85. All right.